Understanding massive particle accelerators and how they work can be fascinating. CERN's Large Hadron Collider, LHC, is a 17-mile-long ring of superconducting magnets, the world's largest stationary particle smasher. It represents the pinnacle of human intellectual achievement. The LHC is so advanced that it can recreate the real conditions in the first moments of the universe. But could this machine designed to unlock the universe's deepest secrets also pose a serious threat? Founded in 1954, CERN is one of the most prestigious scientific organizations in the world, which includes 23 member states and a large number of experts. It is a center for collaboration and innovation. The LHC is CERN's flagship, but it is only one part of a vast network of accelerators and experiments. Imagine a circuit, but not for vehicles. This piece is for subatomic particles, showing expert precision and persistence in space. The LHC accelerates protons to almost the speed of light, imitating the energy of the universe during the Big Bang. The collisions produce higher temperatures than in the center of the Sun. Magnets guide the protons on their path, while cooling systems keep the magnets at temperatures cooler than room. The beams inside the LHC are designed to collide at 4 points around the ring, corresponding to the 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each detector has a specific purpose that studies different aspects of particle physics. Together, they act as huge cameras that record snapshots of these collisions. Analysts then sift through the debris for signs of the elusive Higgs boson, also known as the God particle, and other clues about the fundamental structure of the universe. By studying the microcosm, we gain information about the world. But with every answer comes a new question, and with every discovery comes a new challenge. The LHC is not just a scientific instrument. It is a testament to human curiosity and progress. It embodies our relentless pursuit of knowledge and desire to understand the fundamental forces that shape our universe. However, in pushing the boundaries of understanding, we must also consider emerging ethical and existential questions. In the hallowed halls of CERN, where the limits of human understanding are constantly expanding, a frightening revelation has taken place that will shake even the most prepared scientists. Brian Cox, a former CERN expert and prominent voice in the field of particle physics, recently made a statement that both intrigued and alarmed the world. Cox's words sounded poignant. CERN's Large Hadron Collider aims to mimic a miniature Big Bang. Yes, you heard that right, a smaller version of the event that created our universe. The physicist also explained the implications of this goal, highlighting the extraordinary new discoveries of the LHC. This includes the opportunity to unlock the secrets of the Higgs boson and study dark matter, the mysterious substance that makes up a significant part of the universe. Imagine holding the power of creation in your hands, the ability to call forth the entire fabric of the universe. This is an attractive prospect, but fraught with risks. The mini-explosion is not just a theoretical concept. This is the tangible reality of the LHC. Temperatures, pressures, and pure energy mimic the conditions of the early universe, recalling the beginning of existence. But with such power comes responsibility, and the question contains a potential danger. What if something goes wrong? In 1978, Russian physicist Anatoly Bugorsky experienced an accident that changed his life forever. Bugorsky was working at the U-70 synchrotron at the Institute of High-Energy Physics in Protvino, Russia, when an accident unexpectedly put his head directly in the path of a proton beam. A beam of unimaginable power passed through his skull, entered the back of his head, and exited his nose. Bugorsky saw a flash brighter than 1,000 suns, but felt no pain. The beam caused extensive damage, burning through tissue and bone, but he remained conscious and walked to the hospital for treatment. The consequences were both tragic and exciting. The beam caused localized tissue damage resulting in hearing loss in one ear and partial facial paralysis. Remarkably, Bugorsky's cognitive abilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy, but a powerful example of the enormous power and scientific danger of particle accelerators. The dangers of particle smashers like the LHC should not be taken lightly. Possible unintended consequences, manipulation of the fabric of reality. This is not science fiction, but real concerns expressed by real scientists. The mysteries of the universe are not mere toys, but tools of immense power. One of the most puzzling and interesting problems with the LHC experiments is the possibility of creating a small black hole. Black holes are regions of space-time where gravity is so strong that even light cannot escape. They are giant vacuum cleaners, star-eaters, and mysterious creatures that lurk in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is both exciting and terrifying. Could this black hole eventually spiral out of control and swallow the Earth? However, CERN experts confirm that any black hole created would be small and disappear almost immediately. This small possibility created debate, fear, and respect of our power. Understanding how the LHC can create a black hole involves the basic mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy involved is so enormous that it can twist the fabric of space-time itself. Imagine that a trampoline is stretched and a heavy object is dropped on it. The surface bends and deforms. If the weight is significant enough, it can cause depression so deep that everyone close is drawn into it. This is a simplified analogy of what might happen at the LHC in the field of quantum physics, where the rules of the universe are both strange and wonderful. There is a theory that extra dimensions may exist in our universe. If these
dimensions exist, LHC collisions can exploit them and create a gravitational funnel that forms a small black hole. This complicated dance of particles has even attracted the attention of some world-renowned scientists, including the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic vacuum rupture, an inevitable event that would destroy not only the Earth, but the entire universe. The respected British cosmologist and astrophysicist Sir Martin Rees also expressed his concern about the experiments at CERN. In his book, The Future of Mankind, he explored the potential dangers associated with particle accelerator experiments, including those at CERN. His words were not just a warning. They were overshadowed by a sense of existential dread. He talked about a worst-case scenario where a destructive experiment could create a condition called vacuum instability. This instability could in principle trigger a phase change that would vibrate through space-time, causing a catastrophic event that could engulf the entire universe. The concerns of Rees were not limited to theoretical understandings. He determined the probability of their catastrophic consequences, however small. However, he argued that even a slight possibility should give us pause. The stakes are unimaginably high, and the margin for error is very small. CERN experts have carried out extensive analyses, simulations, and verified theories to protect the safety of the LHC. Brian Cox himself recognized the importance of continuous monitoring and acknowledged the boundless fears and concerns surrounding LHC operations. But he stressed that strict security measures, extensive controls, and protocols ensure that LHC operations are carried out with the utmost precision. Cox confirmed that the energies involved are within the range of energies naturally encountered by Earth, and the probability of a permanent black hole forming is extremely small. Even if it did form, the researchers say, it would be so small and unstable that it would evaporate quickly. Stephen Hawking predicted a phenomenon known as Hawking radiation. It would be a fleeting moment of overwhelming wonder, a little glimpse into nothingness and then gone. Some have speculated further, suggesting that the LHC experiments may open a door to another universe or dimension. Although rejected by famous scientists, the idea captured the imagination of many and became a subject of fascination, fear, and even legend. What is beyond our reality? Can we accidentally release forces or beings we don't understand? The possibility of opening a portal to another dimension has even been dramatized in various media channels, fueling the fire of uncertainty. But how did this belief come about, and what does it mean in the context of scientific research? The concept of parallel dimensions is not new in physics. The theory of language, contender for the most unified theory, suggests that there can be more than the obvious three dimensions of space and one time. These extra dimensions can be compressed or hidden from view, but in theory they can be accessed or exposed under extreme conditions. Now imagine the LHC as a massive key that unlocks doors that have been sealed since the dawn of time. When protons collide at energies that have never been reached on Earth, they can essentially cause space-time to be disrupted or even torn apart. These interruptions can open paths beyond our reach, like cracks in the vast wall that separates us from the unknown. The consequences would be like dropping a rock into a completely still pond. The impact causes ripples, disturbances that spread and affect everything they touch.